Hello students, today we are going to explore a beautiful property of a special quadrilateral, the cyclic quadrilateral. So grab your geometry tools and follow along. Now let's start with this circle. I've drawn 4 points along the circumference of this circle, A, B, C and D. When we connect these 4 points to form a quadrilateral, we get what's called a cyclic quadrilateral. And what makes this cyclic quadrilateral special is that all of its vertices lie on the circumference. That's what cyclic means. It is inscribed in a circle. Now, let's try to prove this by applying the inscribed angle theorem. What is inscribed angle theorem? The inscribed angle theorem states that any angle subtended at a point along the circumference of a circle is half the angle subtended at the center of the circle. So, relating that, the figure shown here, the angle alpha subtended at the point A on the circumference of the circle, which means angle DAB, is equal to half of the angle subtended at the center of the circle, which is angle DOB, which means angle DOB is equal to 2 into angle DAB, which is alpha, which means angle DOB is equal to 2 alpha. Similarly, the angle mu subtended at the circumference on point C of the circle, which means angle BCD, is half the angle subtended at the center of the circle, which is angle BOD, which means angle BOD is equal to 2 mu. Now, please look into the center of the circle. Can we easily notice that angle 2 mu and angle 2 alpha sum up to 360, which means alpha plus mu is equal to 360 degree by 2. As you can see, alpha is equal to angle BAD and mu is equal to angle BCD are actually the opposite angles of the cyclic quadrilateral ABCD. Please note that the same applies for the other pair of opposite angles also, that are angle ABC and angle CDA. Hence, it is proved that the sum of either pair of opposite angles of a cyclic quadrilateral is always 180 degrees.
Let us prove this practically. For this, the materials we require are a white paper, a ruler, a pencil, a compass, and a protractor. Now, with any radius as you wish, but please ensure that fits within the dimension of the white paper. With that radius, draw a complete circle. Now, using the pencil, along the circumference of the circle, mark 4 points. Points A, B, C, and D. Now, using the ruler and the pencil, connect these 4 points with straight lines. Connect A to B, then B to C, C to D, and then D to A. Now what we get is a complete cyclic quadrilateral with all of its vertices along the circumference of the circle. Now let's take the protractor and measure the angle A, which is angle BAC. As you can see, it is coming to 84 degrees. Now let's measure the opposite angle C, which is angle BCD. As you can see, it is coming to 96 degrees. Now let's try to add them up. 84 degree plus 96 degrees. What do you get? That's right, 180 degrees.
So, here is the golden rule. If a quadrilateral is inside the circle with all of its vertices along the circumference of the circle, then its opposite angles are always supplementary. which means that opposite angles always sum up to 180 degrees. In the upcoming stages, we will take you through the animated models and interactive tools where you will drag, measure, and prove this concept yourself. But remember, always check if the quadrilateral is cyclic before applying the 180-degree rule. So, ready to explore? Let's go.